All right, so here we go. Now we're going to start the section on solving quadratic equations or solving trigonometric equations when we have equations that are of quadratic type or in quadratic form. So I talked about this before, I mentioned this before. So what we're looking for is, hey, does it have the form of ax squared plus bx plus c, right? If it does, then we can say, hey, it's quadratic in form, and then we can use all of those techniques, all those tools in our toolbox that we've learned from algebra, college algebra, whatnot, to solve them. Okay, so let's do this example here. So the example is 2 sine squared x minus sine x minus 1 equals 0. And we're interested in the interval from 0 to 2 pi, right? So we want to solve this in that interval. Now, notice that this is quadratic in form, right? Because it has a squared term, a single term, and a constant, right? So it fits this form, right? So let's treat it as if it was a quadratic equation, right? And how would we solve something like this, right? Well, think of it as if it was just 2 times u squared minus u minus 1. How would we factor that? We would use the AC method, right? To decompose the middle term, right? So let's just do that, right? So we're going to take 2 and negative 1, and so that gives us negative 3, and we want to know, hey, what two factors of negative 3 will give us negative 1 when we add them, okay? What will work? Or excuse me, not negative 3, negative 2. So we're taking 2 and negative 1, multiply them together, we get negative 2. And we want two factors of negative 2 that add to negative 1. Of course, it'll be 1 and negative 2, right? 1 and negative 2 will do it. So we want to decompose the middle term, so we're going to say 2 sine squared x, and we're going to say minus 2 sine x plus sine x minus 1 equals 0. Okay? Now we're going to group these. We're going to factor by grouping. So that means we're going to group these two and these two, right? So then now I'm going to factor out a 2 sine x. So that means 2 sine x times sine x minus 1 plus, now we're going to factor out nothing, right? It's already got sine x minus 1, so we could just put in like an imaginary 1 there, right? 1 times sine x minus 1 equals 0. So now, look at that, now we've got another common factor. And so now I'm going to factor again. So if I factor out the sine x minus 1, I get sine x minus 1, and then times what's left over. 2 sine x plus 1 equals 0. And now look at that. Now I can use the zero product principle to solve for each one of these factors. So that would mean sine x minus 1 equals 0, or 2 sine x plus 1 equals 0. Okay, so this means over here, sine x equals 1, and over here, sine x is going to equal negative 1/2, right? So now I got to find out, hey, what values of x will give me a sine of that equal to 1, right? So the sine of what values give me 1, and the sine of what values give me negative 1/2. Okay? Okay, so sine is positive in the first and second quadrant. So when is sine equal to 1 in the first and second quadrant? It's only going to be equal to 1 when x, right? When x is equal to pi over 2. Right? Remember, from 0 to 2 pi, right? It's only positive in the first and second quadrant, and it's only going to be 1 equal to 1 at pi over 2. Now what about here? Negative 1/2. When is sine x equal to negative 1/2? Well, it's only negative in the third and fourth quadrant. So when is it equal to a half? Well, this would correspond to what? This is going to correspond to a 30-degree angle. Okay, so this means that x would equal what? X would have to equal 5 pi over 6, or it'd be 11 pi over 6. Oops. Oh, no, I'm sorry. That's less than pi. 7 pi over 6. Yeah. Remember, third and fourth quadrant. So third and fourth quadrant would give us 7 pi over 6 and 11 pi over 6, and then of course pi over 2 will also do it. And so those are the three solutions, right? So we've got, so if we were doing this, then we would say x is either equal to pi over 6, or excuse me, I keep doing that. Pi over 2, 7 pi over 6, and 11 pi over 6. And those are our answers. Okay, and again, you can find these on the graph, because again, these correspond to the x-intercepts, right? So you can verify that using your graphing calculator. Graph it, and then find all the intercepts, and you'll see that those are correct.